Welcome to Algebra 1, Unit 4-1, Lesson 2. I had a typo on here, so I had to erase it and type my 2. So today's objective is scholars will interpret and find the rate of change of absolute value functions. So we are still talking about absolute value functions. So let's look at this first problem. Jay rides in a boat from his home to his friend's home in a neighboring state. The graph of the function d of t equals 30 times t minus 1.5, the absolute value of t minus 1.5, shows the distance of the boat in miles from the state line at t hours. Assume the graph shows Jay's entire trip. So you see here is a picture. Jay is in his boat. He's traveling towards the border. This is the border. Then he's got to travel over the border to his friend's house. Here is our graph. You see where he starts. So here's our question. How far does Jay travel to visit his friend? How can we use this information to figure out how far Jay traveled to visit his friend? Well, let's think about this for just a minute. If we look more closely at our graph, we can see that the function is decreasing from the time Jay starts his trip, from time 0 to time 1.5. My function is decreasing. And then our minimum distance from the state line is 0. What does that mean? If we are 0 miles from the state line, that means we're at the state line. And then the distance is increasing again. So as Jay approaches the state line, this is him approaching the state line, and then he keeps going past the state line, and then he goes further and further away from it. So how far does Jay travel to visit his friend? Well, let's see. On this part, we can see he started at 45 miles from the state line. He went to the state line, which is at 0 miles. And then at the end of the 3 hours, he was 45 miles from the state line again. So how far did he travel? Well, he traveled 45 miles to the state line and then 45 miles from the state line for a total of 90 miles traveled. Remember that this graph is not going to look like his trip. He didn't go close and then go away. He traveled in a straight line the entire way. So the graph does not look like what his route looked like. But he traveled a total of 90 miles. So in the same situation, how does the graph relate to the domain and range of the function? So we've been talking about the domain and the range of these functions. So the domain of this function is our possible x values. Well, we can see our possible inputs. We start at time 0 and we go to time 3. So our domain is 0 is less than or equal to x, which is less than or equal to 3. Our range, the furthest he's away is 45. The closest he is 0. So our range is 0 is less than or equal to y, which is less than or equal to 45. So in this case, because we are looking at a specific instance, our domain is limited, as is our range. Our range is always limited, but in this case, it's much more limited between 0 and 45. So let's now look at this situation. A cyclist competing in a race rides past a water station. The graph of the function, d of t equals 1/3 times the absolute value of t minus 60, shows her distance from the water station at t minutes. Assume the graph represents the entire race. What does the graph tell you about her race? So let's think about that for a minute. How long was the race? Well, if this graph shows the entire race, we don't have a value here. Oops. Guess I'll write a little bit clearer. We don't have a value here, but we can see by the pattern that I should increase by 50, so it'd be 120. So the race lasted 120 minutes. How far did she go? So let's think about that. We time and distance. So she started out 20 kilometers away from this, the water station, right? And here she's at the water station. And then she ends up at the end. How far? And again, she's 20 kilometers from it. So what's the total distance? The race course was, we had 20 here and 20 here. So it was 40 kilometers. And what else do we know? It looks like the cyclist moves at a constant rate. Because we see our straight lines. Cyclist moved at a constant rate. If I was asked for the domain of this function, the domain is 0 to 120. 0 is less or equal to x, which is less or equal to 120. And then our range, we start out at 20. So our range is 0 is less than or equal to y, which is less than or equal to 20. So there's our domain and our range. Domain and range, sorry. Okay, so let's go on to, so determining the rate of change. We sort of looked at this already, but let's look at this again. So Jay rides the boat from his home to his friend's home. So we're looking at the same thing. We have the same graph. What is the rate of change over the interval 2 to 2.5? So we're looking at the interval between 2 and 2.5. So remember, to do our rate of change, we just do change in y, y2 minus y1 over x2 minus x1. In this case, my y went from 30 down to 15. So I have 30 minus 15 over 2.5 minus 5, not minus 5. 2.5 minus 2. So that gives me 15 over 0.5, which if I divide gives me 30. So that's my rate of change. What does it mean in terms of this situation? Well, I'm comparing distance and time. So he was going at 30 miles per hour. It was his speed. Okay, so Kata. Look at this one. Kata gets on a moving walkway at the airport. Then, 8 seconds after she gets on, she taps Lisa, who is standing alongside the walkway. The graph shows Kata's distance from Lisa over time. So we're going to calculate the rate of change in her distance from Lisa from 6 seconds to 8 seconds, and then from 8 seconds to 12 seconds. And then what do the rates of change mean in terms of Kata's movement? So this is an interesting one. We're looking at two different sections. So first we're looking at 6 seconds to 8 seconds, which is here to here. So we're looking at this section here. So to find the rate of change there, we're going to do change in y. My y values go from, let's say looks like she's about 6 feet away to being 0 feet away. And then from being 6 seconds minus 8 seconds. So I have 6 over negative 2, which is negative 3. So that section is going to be negative 3. And then the other section I have is from 8 seconds to 12 seconds. So here's 8 seconds. Here's 12 seconds. It looks like the points are, so we have 8, 0. But then we had the point 12, and that looks like 1210. So, in this case, by change in y goes from 0 to 10. X goes from 8 to 12. I get negative 10 over negative 4, which is positive 2.5. So what do these rates of change mean in terms of Kata's movement? So, negative 3, her distance was decreasing. So as she moved towards, her distance was decreasing. Does that make sense? This is her distance from Lisa, remember? And then as she moved away, her distance was increasing. She was going further away. It looks like she was moving, about the same speed. These distances are estimates. Okay, so go ahead and try some of these on your own.